Hello guys, thanks for coming back again. If you have subscribed, if you are yet to subscribe, please click on the subscribe button and also on the bell beside it. That will notify you when we drop a new video. Thank you. Happy New Year 2022. I wish you all the best in this new year that comes our way, and every time I wish you the best. Okay, in this video, I just want to do a new year video for our WAEC candidate, and I just want to play around with some reactions in organic chemistry, of which is important for you to know them. And few of those reactions are written on the board here. We have cracking, and we're going to make brief explanation on each reactions. We have cracking, we have substitution reaction, we have addition reaction, we have polymerization, we have fermentation, we have esterification, and at the same time we have saponification. All this is just to brush up our mind based on all these reactions and probably what they mean. So I'll start with cracking. What does cracking mean? I think the definition says it involves the breaking down of bigger organic compound by the action of heat alone. So however, I will tell you that we have two types of cracking. We have the thermal cracking and the catalytic cracking. So thermal, we have cracking, and we have the thermal, and we have the catalytic. Actually, the thermal cracking has to do with heat. Both has to do with heat actually, but I think from the word catalytic, you should know that this one involves the use of a catalyst. And what makes the difference is that this has been used, the thermal cracking has been used over since, and it was characterized by inability to control the type of products that will eventually be formed. Okay, it means you cannot actually determine, or you cannot control the type of compound you wanted to form. But in this catalytic cracking, you will be able to control or try to get a particular compound formed in that catalytic cracking. That is what makes the difference, the use of catalyst, and this process takes place within a temperature of 450 degrees Celsius in the presence of the catalyst. So, and that is cracking for you. So, and actually there is no chemical equation I could use here to explain further. So, but that is just the major thing. You can go ahead, read further on that. So now let's look at substitution reaction. This reaction is common to alkanes. Alkanes is one of the homologous series in organic chemistry, and they are referred to as the saturated hydrocarbon. The alkanes consist of only carbon chain and hydrogen attached to them. Just like the first member, methane, we have ethane, propane, butane, pentane, and so on. If you consider their structure and their molecular formula, you would discover that they are only containing carbon chain and then hydrogen attached to the chain. So in this case, what I'm trying to explain here is that when you talk about substitution reaction, it takes place with alkanes alone. Reason being that they don't undergo any reaction other than substitution, because they are saturated. Saturated, in another way around, let me put it in a more general English, they are contented, which means they hardly undergo a reaction. They are very slow in undergoing reaction just because they have a single bond in their carbon chain. All true. That is the reason why they are saturated hydrocarbons. They have single bond in their carbon chain. Okay, let's just tag that as the major reason why they are called saturated hydrocarbon. So in this case, they undergo substitution reaction, and when they undergo substitution reaction, the hydrogen attached to the carbon chain are being replaced by groups, which is either functional group or atoms. For instance, if I have methane, CH4, I'm trying to explain substitution reaction now. If I have methane, CH4, this CH4 might be combined with chlorine, possibly to remove the one hydrogen and replace with one chlorine. So in that case, we are going to have, and you have to replace all the Cl2 so you can supply excess chlorine so that more of hydrogen will be substituted with chlorine. So in this case, I'm going to have CH4 plus Cl2. So I may eventually have CH3Cl, and don't forget hydrogen is being removed. So and the hydrogen of which we combine with the air, the remaining chlorine here to form HCl. I think you see that. So which means this reaction is a substitution reaction. One of the four hydrogen here have been substituted for chlorine in this product. So that's a substitution reaction, and it takes place for every member of the alkanes. You can substitute chlorine, and that process we can term it as chlorination. You can also substitute any of the halogen apart from chlorine. You can substitute bromine, you can substitute iodine, and at the same time you can substitute functional group instead of chlorine or any of the halogens. You can substitute a functional group like OH and so on. So that is substitution reaction. It involves the replacement of hydrogen in the chains of the alkane by atoms which can either be halogen or functional groups. So that is all about substitution reaction. So now let's move to what we call addition reaction. So what is addition reaction? Talking about addition reaction, only the unsaturated hydrocarbon undergoes addition reaction. And when I say unsaturated, I mean compounds, organic compounds that has triple or double bond in their carbon chain. For instance, we have 18. If I say 18, that means I'm going to have C, double bond between the carbon. Then according to the formula, this double bond was gotten by a replacement by a removal of two hydrogen. So we have, I think this is two bonds attached to the carbon. So we have H here, then I think we're still going to have H here and H here. This is 18. So don't forget that 4 bonds goes to every carbon. So this is 1, 2, 3, 4. And this is 1, 2, 3, 4. So this is 18. So 18 can undergo an addition reaction. And how does addition reaction takes place? It involves the addition of an attacking agent or atom or group along the carbon chain of an unsaturated hydrocarbon. Yeah, this is an unsaturated hydrocarbon. So if I want to eliminate one of these double bonds now, that means I'm going to add an attacking agent. It can either be halogen, it can be oxygen, and the oxygen we definitely gotten from a particular compound. You cannot just add oxygen directly because that will be a reaction called combustion. Actually, combustion is also an addition reaction with unsaturated hydrocarbon. So let's consider adding of KMnO4, that is oxygen gotten from KMnO4. So the oxygen will be added to it to form epoxy ethane and so on. So for instance, if I add H2O, okay, I think the KMnO4 is supposed to be diluted. So with let me just put this oxygen. So because I don't need to write KMnO4 in full because the oxygen in it is the major one, is the major concern. So if this is added, then you're going to have this H, 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 H. Then you have oxygen here. So this is what we call epoxy ethane. Epoxy ethane. So this is an example of addition reaction. Actually, this is the reactant, and this is the product of the reaction. This is epoxy ethane, and that's addition reaction. You can end up adding oxygen to this. Chlorine to this. You add chlorine. So suppose I added chlorine in the first place. What will I have? If I added chlorine, that is plus Cl2, what I will eventually have is C, then H here, then H here, then H, then H, then I will have Cl, Cl. So that is what I will have, and that is addition reaction. Can you see that the double bond has been eliminated? So that is that on addition reaction. Okay, let's go for polymerization. So when you say polymerization, what does it mean? When you say polymers are bigger organic compounds. And when you say polymerization, it involves a reaction of which polymer is formed. And how does polymer forms? When you say something is poly, which means it contains so much small molecules. And those small molecules are called monomers. So then monomers combine to form polymer. So the process in which smaller molecules, which are called monomers, are linked together by a certain bond to form bigger molecule. That process is what we call polymerization. And the bigger molecule formed is called polymer. For instance, if I have 18, I think I used to talk about this. When you have a lot of 18 linked together, you form polyethylene. You form what? Polyethylene. So I think you've heard about polyethylene earlier. So that is how polyethylene is being formed. Polyethylene is formed as a result of a reaction called polymerization, and the monomer of which is involved in this polymerization is ethene, and that is why it is called polyethylene. Okay, now let's move to fermentation. Fermentation has to do with breaking down of bigger molecules such as starch, glucose, and all that to produce smaller molecules like alcohol. So if I have a molecule of starch or glucose rather, so C6H12O6 undergoes a breaking down process by the action of a bacteria and an enzyme called zymase. Okay, I'm going to end up forming two molecules of ethanol plus two molecules of CO2. That is what I will eventually form at the end of the reaction. So this is ethanol, which is smaller to this molecule, and this is glucose, and this is CO2, which is carbon dioxide rather. So this reaction is called fermentation, and it occurs as a result of the action of some bacteria or microorganism, and at the same time an enzyme must be present. So the enzyme present in this particular reaction is what we call the zymase. So, and that is fermentation. It has to be breaking down in the absence of oxygen. Let me just say that also. It's an example of an anaerobic respiration. Okay, let's move to esterification. Let's move to esterification. When you talk about esters, I think esters are organic compound with general formula CR prime. So the R prime indicates that the R might be the same or different. So, and the R belongs to the alkyl group. I think the general representation of alkyl is what is R. And this product could be formed by the reaction called esterification. And what does esterification means? It means the reaction between the family alkanol and carboxylic acid. For instance, if I have ethanol C2H5OH reacting with ethanoic CH3COOH, the products that will be formed after esterification are majorly two, and that is the ester and water. So, and how does that happen? This hydrogen is being removed here. So I think RCOOH. So I think I'm going to have my COO. The OH will be removed, combined with this H to form water, and I'm going to have C2H5. Then this being removed, then you're going to have COO, CH3, CH3. So R indicates this, then COO, then this is another R. So the R are different. The R are different. Actually, this can be C2H5 also, so which means you're going to have C2H5, COO, C2H5. So, but this is C2H5, COO, CH3, and this is called methyl ethanoate, because the esters, they have a general name called alkanoates. So this alkanoate, the name of every member will end with ate. So which means this is going to be called the methyl ethanoate. That is how it is named, methyl ethanoate, and this is the product. And don't forget, I told you that this joins with this to form H2O. And that is water. So the two major products of esterification is the esters and water, and the reaction takes place between an alcohol or alkanol family with carboxylic acid. So now let's move to saponification, and that process involves the formation of soap. So what is saponification? So when you say saponification, it involves the reaction between fat or oil with a caustic alkali. So when I say caustic alkali, we have two major types, that is caustic soda or caustic potash. Caustic soda is sodium hydroxide, caustic potash is potassium hydroxide. So when oil or probably fat react with any of these two, there is a process called saponification, and that involves the formation of a soap. And that is a kind of neutralization reaction because the base reacted with the acid content of the oil or the fat, and neutralization occurs. So the salt produced is regarded to as the soap, and at the end of the day, we have another product byproduct, which is called the propan 1,2,3 trial, or you call it the glyceride. So that is saponification. So saponification involves fat or oil plus caustic alkali to end up producing soap plus propan 1,2,3 diol. That is saponification. You can generally define that as the hydrolysis of fat or oil by caustic alkali to produce corresponding soap salt and glyceride. Okay, thanks for watching. Please subscribe to our channel. It's free. Thank you.